Hi students, problem number 5. A proton, a deuteron and an alpha particle with the same kinetic energy enter a region of uniform magnetic field moving at right angle to B. What is the ratio of their radii of circular paths? Just now in the previous video, in problem number 4, we have considered the same three particles having the same velocity. Okay, in this problem they are having the same kinetic energy. Okay children, first you should know that when three particles like the proton, deuteron and the alpha particle enter with the same velocity, they cannot have the same kinetic energy, is it not? Because their masses are different. So here the situation is different. They all have the same kinetic energy is given here. So we have to approach in a different way. Yes, we all have studied the relationship between the kinetic energy and momentum, is it not? This is extremely very important for the Neet and JEE attending students. The relationship between kinetic energy and momentum, so many numericals will appear. Okay, so the relationship between kinetic energy and momentum, linear momentum. Okay, what is the relationship between kinetic energy and momentum? E kinetic is equal to P square divided by 2m. This is the relation. Okay, or P square, momentum square, P square is equal to what? 2m into E or Ek. Or momentum P is equal to square root of 2 into m into E kinetic. Okay students, this relationship now in the 11th standard also we have studied. The same we are going to use now. What is momentum? Linear momentum is the product of mass into velocity only, no? So I can also substitute. Therefore momentum is the product of m into v. Mass into velocity. So this is equal to square root of 2 into m into E kinetic. Like this I am going to substitute. This is a very important relationship for solving such problems. Okay, now you tell me what will be the path of the charged particle when it moves at right angle to the magnetic field. It will be clearly circular, is it not? Okay. When it is moving in a circular path, which two forces we are going to equate? The magnetic Lorentz force is equal to the centripetal force. So once again, Q V B is equal to m v square by r. So cancelling this power of velocity and this term velocity, therefore the radius of the circular path is equal to what? mv divided by qb. Just now we used the same relation in the previous numerical also, is it not? So the radius of the circular path is equal to what? mv divided by qb. What is the product of m into v? That is equal to the linear momentum. I am going to substitute for mv from here. So instead of this mv, what can also be substituted? We can also substitute, okay? mv is equal to square root of, so in the numerator, square root of 2m into E kinetic. Okay, divided by qb. So this is the equation we require. So now you read the problem. They all travel with the same kinetic energy in the same field B. So B is the same and the kinetic energy also is the same. So you see here, so this kinetic energy is constant, B is constant, 2 also is constant. Therefore R is proportional to square root of m divided by q. So this is the step which we require. So the proton, deuteron and alpha particle, as you know that proton is 1h1, deuteron is 1h2 and the third one is alpha particle is helium 2-4. So I will take it. This is q1, this is m1, this is q2, this is m2, this is q3 and this is m3. Is it not? So R1. So R1 is the radius of circular path of a proton. So it is Rp. So this is proportional to square root of m1 divided by q1, square root of m1. So what is the square root of m1? m1 is 1. So this is proportional to square root of 1 divided by charge q also is 1. So this is proportional to what? 1 by 1. Right? Next, the radius R2 of the circular path of the deuteron. So RD is proportional to square root of m2 divided by q2. So it is proportional to the square root of m2. So what is the m2 here? It is 2. Therefore, the numerator is square root of 2 divided by, what is q2? It is 1 unit. So this is root 2 by 1. And the radius of the circular path of the alpha particle is taken as R3 or R alpha, and it is proportional to square root of m3 divided by charge q3, that is proportional to. You see here, what is that mass? The mass of the alpha particle is having 4 units. So square root of 4, I will write here square root of 4 divided by q3. What is q3? q3 is 2 unit. So this is 2 and it is proportional to. What is square root of 4? That is 2. So this is 2 divided by 2 is proportional to 1 by 1. Okay. Therefore, the ratio of their radii is R1 is to R2 is to R3 is equal to 1 by 1. Okay. Is to root 2 by 1 is to 1 by 1. Okay. Or this is equal to 1 is to square root of 2 is to 1. Okay. So I will rewrite R1 is to R2 is to R3 is equal to 1 is to root 2 is to 1. Now you check here. Option A is 1 is to square root of 2 is to 1. Option A itself is the correct answer. Therefore, the ratio 1 is to root 2 is to 1. That is option A is the correct answer. So first, this type of problem, when you learn, you write the different relationships among the terms again and again. Understand? Don't have a fixed formula for all these types of problems. If at all you have forgotten also from where we have to start, you have to initiate. The two forces should be equated. The magnetic Lorentz force BQV is equal to the centripetal force mv square by r. From there you can again continue and pick up these equations. Okay children, I hope you must have understood well. Fine.